Welcome to Bosons Botany, and from this video onwards I will take up the topic light reaction, which is divided into non-cyclic and cyclic photophosphorylation or cyclic and non-cyclic reactions. Before I proceed, I would like to take up the two main important points, which are PS1 and PS2. On my left hand side here, as you can see, first point is PS1. So PS1 is basically representing P700 reaction center. Why P700? Because PS1 is known to absorb light energy in the range of 680 nanometer or above 680 nanometer of wavelength. Therefore, the reaction center of PS1 is basically P700. The second point is PS1 is composed of protein which is containing iron. So the protein which is present in PS1 is basically containing iron, and therefore it is equivalent or similar to that of ferrodoxin. The next point is pigment molecules absorb light energy in the range of 680 nanometer and more, or high wavelength range. This is the sign of wavelength range. That is, PS1 is known to absorb light energy in the range of 680 to 700 nanometer of wavelength, and therefore the reaction center is P700. The next point is this absorbed light energy is then sent to the reaction center, that is P700, which is used up to transfer electrons to the low potential acceptor via intermediates, reducing NADP plus into NADPH2 plus. So I have already described this particular point before, that chlorophyll A molecule is known to create or known to form the reaction center found in both PS1 and PS2. So this chlorophyll A molecule, which is forming the reaction center in both the photosystems, is surrounded by the accessory pigments, which are carotenoids and xanthophylls, along with the remaining chlorophyll molecules, which are chlorophyll B and chlorophyll C. So this particular pigment system, which consists of the accessory pigments and the remaining chlorophyll molecules, absorb light energy in the range of 680 nanometer or higher than 680 nanometer to transfer this absorbed light energy in the form of electrons to the reaction center of PS1, which is P700, and from this reaction center of PS1, which is P700, electrons get transferred to the electron acceptors, which are basically belonging to low electron potential or low potential via intermediates. These intermediates have high electron acceptors to reduce NADP plus into NADPH2 plus. Why the flow of electrons occur from high electron potential to low electron potential? Because molecules or intermediates which are having high electron potential have the tendency to lose or donate electrons to those acceptors or those intermediates or those molecules which are having low electron potential. Low electron potential, as you can make an idea from the name, that it has a great tendency to accept electron and to get reduced. So this electron, which is absorbed by the pigment system, get transferred to the reaction center of PS1, which is P700, and this particular electron then flows to the low electron or low potential acceptor via intermediates, reducing NADP plus into NADPH2 plus. So NADPH2 plus is the first assimilatory powers which is synthesized only in case of PS1. Okay, so this is very important, that is PS1 is involved in the synthesis of one of the most important assimilatory powers, which is NADPH2 plus, by the reduction of NADP plus with the help of electron flow. The next point, PS1 is involved in both cyclic as well as non-cyclic photophosphorylation or cyclic and non-cyclic reaction of light reaction, and PS1 is present in the stroma laminae and the margins of grana. So these lines are very important. That is, PS1 is found, or it is active in both non-cyclic as well as cyclic reactions, and it is present in the stroma laminae and the margins of the grana. The last point, PS1 is active only, PS1 is active both in red as well as far red light. So these are some points regarding PS1. The next topic is PS2. So PS2 is basically representing the reaction center, which is written as P680 because the range of wavelength which is absorbed in case of PS2 is basically 680 nanometer or below 680 nanometer of wavelength. So in PS1 the range was 680 nanometer and above 680 nanometer, or 680 to 700 nanometer of wavelength range in case of PS1. But in case of PS2, the range of absorption is 680 nanometer or below 680 nanometer of wavelength. The second point is PS2 does or shows photooxidation or photolysis of water. That is the release of oxygen molecule, hydrogen ion or hydronium ion or proton, and electrons. So this particular point is important, and this is the distinguishing feature of PS2. That is, it is known to show the reaction which is commonly known as photooxidation or photolysis of water to release oxygen molecule, hydronium ion or H plus or proton, and electrons. The next point, I have not mentioned the asterisk point here. I have continued this line here as well. So this is defining the action of PS1 only in case of red light region. PS1 is active only, PS1 is active in both red as well as far red light, but PS2 is active only in case of red light. So PS1 in both red as well as far red light, PS2 in only red light region. The next point is PS2 is involved only in non-cyclic reaction or non-cyclic electron transport and reduces the reaction center of PS1, which is P700. If you come to my right hand side, I don't want to describe these two diagrams in this video, but if you just see and notice this particular region, electrons from PS2 will move like this, and ultimately this electron will reduce the reaction center of PS1. That is, electrons from PS2 going from higher electron potential intermediates to the lower potential or lower electron potential acceptors, ultimately to the PS1 reaction center to reduce this reaction center, which is P700. So electrons moving from PS2 via the intermediates and acceptors of electron ultimately to the PS1, just to reduce this particular reaction center of PS1. So PS2 is basically known to reduce the reaction center of PS1, which is P700. The next point is on the inner surface of thylakoid membrane, that is PS2 is present on the inner surface of the thylakoid membrane. PS1 was found in the stroma laminae and the margins of the grana, but PS2 is present in the inner surface of the thylakoid membrane. The last very important point is no reduction of NADP plus to NADPH2 plus is shown in case of PS2. If you see this diagram, this is the PS1 zone and this is the PS2 zone. In the PS1 zone, there is the reduction of NADP plus to NADPH2 plus in this particular zone. That is, PS1 is involved in the reduction of NADP plus into NADPH2 plus. But this particular reaction is not shown by the PS2 reaction center, because as you can see, there is no formation of NADPH2 plus as it is shown by PS1 reaction center. So there are few important points which are very much asked regarding PS2, which are: first, it does photooxidation or photolysis of water. The second point is it reduces PS1 reaction center. And the third point, no reduction of NADP plus into NADPH2 plus is shown by PS2 reaction center. It is only shown by the PS1 reaction center. So this particular point is very important. There are few important points regarding both PS1 and PS2. These are: both PS1 and PS2 are interconnected by an integral protein complex, which is cytochrome B6F complex. So both these photosystems are interconnected together with the help of an integral protein complex, which is cytochrome B6F complex, and it is commonly known as risky center. So cytochrome B6F complex is known to connect PS1 and PS2, which is commonly known as risky center. The second point is plastoquinone, which is abbreviated as PQ, and plastocyanin, which is abbreviated as PC, are the mobile electron carriers. That is, these two molecules are known to carry electrons or help electrons to move from one intermediate to the next intermediate, or one acceptor to the next acceptor. And this is only possible due to the presence of PQ, that is plastoquinone, and PC, plastocyanin. The next few points are: PS2 is interconnected with cytochrome B6F with the help of plastoquinone, and PS1 is interconnected with cytochrome B6F with the help of PC or plastocyanin. So PQ or plastoquinone is known to interconnect PS2 and cytochrome B6F, whereas plastocyanin or PC is known to connect PS1 and cytochrome B6F. So after jotting these points down, I think the next video will be easy for you to understand both the reactions, which are non-cyclic and cyclic reactions. So in my next video, I will take up these two reactions separately, writing few points to describe their importance in the role of photosynthesis. Thank you.